For the additional mathematics topic that we are sharing today, it's polynomials. So to better understand this topic and solve all the possible questions, there's a couple of topics that you need to master first. So that includes in the algebra, substitution and factorization, simultaneous equation, and also differentiation. So I'm going to share a couple of examples that utilize all this concept. Okay, moving on, I'm going to show you the three things that you're going to learn here. First of all, it is the division process on how do you divide a polynomials. Okay, and what's called a factor and the term divisibles means, and also the remainder. Okay, without further ado, let's go through the division process first. So this thing here, we got 6x cubed minus 5x squared minus 14x plus 40. It was being divided by a x plus 2. So this 6x cubed equation here is actually considered as a polynomial. So for you to divide them, okay, always remember you are trying to get rid of the numbers at the front. So what we have there was we are supposed to figure out what to multiply to the x plus 2 in order to cancel off the 6x cubed over there. So immediately I noticed that when my 6x squared multiply with x, I will obtain a 6x cubed. Okay, and when my 6x squared multiply with 2, then I'll get plus 12x squared. Here comes the tricky part. The normal division process that you will learn in your year 1 to 6, okay, the relationship between the upper numbers and the lower one is minusing each other. So the same things was being adopted here. So this is the full details over here. So 6x cubed minus 5x squared was being minus off with the entire results that are written down there. So we have to put the bracket down and multiply the negative into two of the variables. So when the negative multiply into the brackets, I will get negative 6x cubed minus 12x squared. Hence the results will be a negative 17x squared. Then I drag the negative 14x down from the top. So now our objective is to try to get rid of the negative 17x squared. So immediately I noticed that when negative 17x multiply with x plus 2, then you get the results of negative 17x squared minus 34x, and the balance will be 20x, and then I bring down the 40. Okay, and the last part, okay, when we multiply it by 20, then you automatically cancel off the entire thing with no balance. So this is the full details calculation. Okay, if you are wondering, you are struggling to understand this, you can always refer to the yellow box that I have there for each and every section. So the red font that I highlighted over there is actually x plus 2, and since there's no remainder, okay, which means there's no balance at the bottom, then it is considered as a factor. And the 6x squared minus 17x plus 20 is actually your quadratic factor. Okay, moving on to the next example, we have 6x cubed minus 5x squared minus 14x plus 40, and now it was being divided by x minus 1. Okay, so when it was being divided, okay, remember the same objective that you have is trying to get rid of the numbers at the front. So x being multiplied with 6x squared will automatically become 6x cubed and cancel off each other. Okay, so 6x squared being multiplied with x minus 1, you will get the result of 6x cubed minus 6x squared, okay, and the difference will get you x squared. Bring down the negative 14x. So now you're trying to get rid of the x squared over there. So x times x will automatically get you x squared. and x times -1 will get you negative x. So the balance from this calculation will be negative 13x, and bring down the 40 over there. So I multiply a negative 13, then I will get negative 13x plus 13. And the balance from this will actually be 27. So this 27 here is the remainder, and our x minus 1 is not considered as a factor because it cannot divide the polynomials completely. It has remainder of 27. So moving on to the next part, I'm going to share a couple of questions that I selected from past year papers, okay, to show you how do they link this topic with the core concept, which is algebra substitution, factorization, okay, we have differentiation and also simultaneous equation. It is given that function f is 6x cubed minus 5x squared plus ax plus b, and it has a factor of x plus 2. Okay, this is the first hint that was given by the question, and the next part is actually and leaves a remainder of 27 when divided by x minus 1. So your objective of the question is to show that b is 40 and find the value of a. So this part is how they assess you on your substitution and are you able to solve the simultaneous equation. So from the factor part, okay, put it equals to 0, shift the 2 to the other side, then you get negative 2. So since it's a factor, when your x is negative 2, it will have no remainder. Okay, substitute this negative 2 into all the x position of the function f or polynomial. Okay, then you will get the results of negative 2a plus b equals to 68. Moving on to the next part of the question, we have leaves the remainder of 27 when divided by x minus 1. So same thing, I set the x minus 1 equals to 0, shift the 1 to the other side. So when my x was being replaced with 1, it has a remainder of 27. So you will see me listing down a equals to 27 over there. By running the calculation, you get your next equation as a plus b equals to 26. So this is your equation 1 and equation 2. Okay, so I list it down over at the side and I'm starting to run my simultaneous equation. So the method I'm using is elimination method. So I took 1 minus 2. Okay, remember to put the bracket on the second equation. So now you have a balance of negative 2a plus b minus a minus b equals to 42. By running a calculation, you will get your a as negative 14. Substitute the a equals to negative 14 back into equation 2. Then you will get negative 14 plus b equals to 26. b equals to 40. And that's how you answer this question completely. Moving on to the next section, we have showing that function f equals to x plus 2 multiplied with px squared plus qx plus r, where pqr's are integer to be found. Okay, so remember, when it comes to this type of question, it's usually linked with previous part. You have already identified a and b, so substitute it into the function f that you have there, and you have 6x cubed minus 5x squared minus 14x plus 40. Okay, so you can see the 2 factor being listed over there, okay, and it has no remainder. So what you're trying to do now is to divide this by x plus 2. So this will be the first division process example that I've shown you over at the front. So repeat the same thing, then you will get 6x squared minus 17x plus 20. If you need the full details on this calculation, you can refer to the previous part. So your P will now be 6, and your Q is negative 17, and your R is 20. So that's how you solve this particular type of question. Moving on to part 3, hence solve that Px equals to 0. Okay, so I listed down the factor and quadratic factor that I've obtained. Then I realized that the 6x squared minus 17x plus 20 cannot be solved, okay, because it doesn't have any real roots. Okay, so how did I know that? Okay, so before I explain this, I have to go through this chart at the side for you. So to better illustrate this concept to you, okay, I have included a calculation at the side here. So first thing, with two real distinct roots. So let's say we were given this 2x squared minus x minus 3. So our b here is negative 1 because we have negative x over there. There's no numbers at the front, so it's automatically treated as 1. Minus 4a, a is 2 and c is negative 3. So by running the calculation, you will get 25 as a result. So our b squared minus 4ac is more than 0. So it automatically translate that it has two real distinct roots. So how do we find the respective root? It's actually through the factorization process. Okay, so 2x squared is actually 2x times x, and 3 is actually 3 times 1. So I cross multiply them, then I get 3x as a result and 2x as the other results. So the bigger numbers always follow the center value, okay, which is the negative x over there. So I put negative at the 3x sides, and then I put plus 2 at the end so that I can adjust it and make it negative x. So transfer the negative to the top and then plus, then I will get two results here, which is 2x minus 3, x plus 1. So the respective x results would actually be 3 over 2 and x equals to negative 1. So this is the example for two real distinct roots. For two identical roots here, okay, we have another equation that goes by 4x squared plus 8x plus 4. So our b here is 8, a is 4, and c is also 4. By running a calculation, you will get your b squared minus 4ac's result as 0. So factorize it. So 4x is actually 2x times 2x, and 4 is actually 2 times 2. Cross multiply them, then you get 2 4x as the results, and put plus on both so that they add up together and become 8x. So your final answer for this will actually be 2x plus 2 squared, okay, and when we shift it to the other side, you will get your final results as negative 1. And for the last part, which is the 6x squared minus 70x plus 20. So this is the quadratic equation with no real roots. I'm going to show you why is it so. So our 6 is actually our A, our negative 17 is B, and C is 20. Substitute in the calculation, you get a negative 191 as the result. So our B squared minus 4AC is now less than 0. Since it has no real root, the only answer that we can get is from the x plus 2. So when x plus 2 equals to 0, our x results will be negative 2. So when your fx equals to 0, our x will be negative 2, and that will be your only answer for this question. So it's slightly tricky, okay? However, if you understand this b squared minus 4ac's concept, then you will know that the only acceptable root will be negative 2. that's pretty much it for this particular question. So I'm going to move on and show you another example. So this question 12 here is asking the function fx equals to x cubed plus x squared plus ax plus b equals to 0. It is divisible by x minus 3. So this is our first hint. When it's divisible, it has the same meaning as a factor. So this part will be a key hint for this question. So same thing, I arrange x minus 3 equals to 0, x equals to 3. So when my x is 3, it has no remainder. So when my f bracket 3, it will have no remainder, so equals to 0. By substituting 3 into x position, I will get my first equation as 3a plus b equals to negative 36. As for the next one, leaves the remainder of 20 when your x plus 1. So x plus 1 equals to 0, x equals to negative 1. Substitute the negative 1 into x position, it will have a remainder of 20. By running the calculation, you will get negative 8 plus b equals to 20. So now we have the two equations that we need. Okay, I list it at the side, then I run simultaneous equation elimination method. So I took 1 minus 2, remember to put the bracket over there, and you get the results as 3a plus b plus a minus b equals to negative 56. By running the calculation, you will get your a as negative 14. By substituting a equals to negative 14 into 2, okay, remember to put the bracket again because it has negative at the front. Then you get your results of b as 6. So that's pretty much it for this first section of the question. Moving on, we have using your value a and b. Okay, find the non-integer roots of the equation fx equals to 0 in the form of p plus square root q, where p and q are integers. Now that we have obtained the a and b's value, you can now substitute it into the equation and get the results as x cubed plus x squared minus 14x plus 6. Divide this with x minus 3 to identify the quadratic equation. Okay, so x squared times x minus 3, you get x cubed minus 3x squared. Then to get rid of the balance of 4x squared minus 14x, I multiply a 4x into x minus 3. Then I get 4x squared minus 12x. And the balance of it will be negative 2x plus 6. Multiply another negative 2 into it. Then you will cancel it completely because it is a factor. So with this x squared plus 4x minus 2, so your a will be 1, b will be 4, and c will be negative 2. Through the formula negative b plus minus square root of b squared minus 4ac over 2a. Running the calculation, you will get negative 4 plus minus square root 24 over 2. Okay, further arrange this, you will get negative 4 plus minus 2 square root 6 over 2. Split these two variables into two fractions. You will get negative 4 over 2 plus minus 2 square root 6 over 2. So after the calculation and simplification, you will get negative 2 plus minus square root 6. So your final answer for this particular section, your p will be negative 2 and your q will be 6. Moving on, we have example 3 here. Okay, so it's a combination of what we have learned earlier. So the function fx equals to ax cubed plus 4x squared plus bx minus 2. Okay, the first hint was given as 2x minus 1 is a factor. Okay, and the next part is actually trickier because they involve two division process. So we have x minus 2 is twice the remainder when fx is divided by x plus 1. So as per usual, approach it step by step. So 2x minus 1 equals to 0. So x equals to 1 over 2. So when your f bracket 1 over 2, it will have no remainder, so it's equals to 0. So since this question is trickier, I skip the substitution process first. I try to digest the information that was given by the question. So when my x equals to 2, okay, is twice the value of x equals to negative 1. So that's what it was trying to deliver to you through the long sentence over there. So when my x was being substituted with 2, it is twice the value it was being substituted with negative 1. So I run the substitution calculation. From part 1, I gotten a plus 4b equals 8 as the final results from there. So try not to leave any fraction in your simultaneous equation because it's harder to calculate. So what I did there was to shift the negative 2 to the other side first and try to make the rest with a denominator of 8. By running the calculation and shift the 8 away through cross multiplication, I will get 8 plus 4b equals to 16. So my a plus 4b equals to 8 will be the final equation. As for part 2, by substituting 2 into the equation, okay, equals to 2 of when substituting negative 1 into the equation. So I have 8a plus 16 plus 2b minus 2 equals to 2 bracket negative a plus 4 minus b minus 2 bracket. Running the calculation and get another equation as 10a plus 4b equals to negative 10. So this too is my respective equation to be used for simultaneous equation calculation. So for this question, okay, I used elimination method, but I took 2 minus 1 instead, okay, because 2 has a positive and bigger value in terms of a. So 10a plus 4b minus bracket a plus 4b equals to negative 10 minus 8. So the balance from this will actually be 10a plus 4b minus a minus 4b equals to negative 18. By running the calculation, you will get 9a equals to negative 18, a equals to negative 2. So substitute a equals to negative 2 into 1, then you will get your results as negative 2 plus 4b equals to 8. b is actually 5 over 2. So that's how you identify your a and b's value. Moving on to the last part where I cover the integration of differentiation into this type of question. So you see this slightly different because there's a dot at the function p over there. Okay, so that dot there or comma is actually trying to tell you we're required to run the differentiation calculation first. So first thing first, okay, you will take out the power of 3 multiplied by 2. So every time after you took out power from the unknown, okay, the power will automatically be minus by 1. So I list down all the full details over there. I have 2 multiplied with a, okay, so the power of 2 being minus by 1. So if there's no power on the unknown, means it is 1. So 1 times b, so the power of 1 being minus by 1. And the last part, the negative 49. So if you notice there's no x, okay, for your own illustration, you can actually put a x to the power of 0 over there. So 0 times 49, okay, x to the power of 0 minus 1. So the last part, all the integer will be cancelled off because 0 being multiplied to it. So we have a balance of 6x squared plus 2ax to the power of 1 plus b x to the power of 0 minus 0, adjust it, and you will get 6x squared plus 2ax plus b. So if you are not familiar with this differentiation topic, okay, I have linked a video at the right hand corner. So click on it, watch through it first, then revisit this question again. So now we have the information given by the question. When p prime is divided by x plus 3, it has a remainder of negative 24. So when my x is negative 3, it will have a balance of negative 24. By substituting this negative 3 into x position, it will be equals to negative 24. So run the calculation and adjustment. You should be able to prove that 6a minus b equals to 78. So as you can see, based on the calculation, I've gotten 54 minus 6a plus b equals to negative 24. Okay, however, since the 6a is in negative, so I shift them off to the other side. Okay, and I bring the negative 24 over to the left hand side, okay, to make my calculation simpler and faster. So now until this step, you already show that 6a minus b equals to 78. Moving on to part 3, the additional information was given here is that it is given that 2x minus 1 is a factor of px. So from the first part, we already identify our first equation. We have 6a minus b equals to 78. So utilize this 2x minus 1 that was given here. I know that when my x is 1 over 2, it has no remainder because it is a factor. Substituting this 1 over 2 into polynomial p, x position, you will get it as 2 over 8 plus a over 4 plus b over 2 equals to 49. Okay, make their denominator the same. Okay, adjust it and you will get 2a plus 4b equals to 390. Okay, you can also write a plus 2b equals to 195. It's optional, whichever you're more comfortable with is acceptable. So now I have my equation 2 over here. Okay, I use the substitution method because it's very troublesome. We have to use elimination method again. So I adjusted from my equation 1, I gotten b equals to 6a minus 78. Substitute equation 3 into 2, I get 2a plus 4 bracket 6a minus 78 equals to 390. Run the calculation, then you'll get your a equals to 27. And substituting this 27 into equation 3, then you will get your results as b equals to 84. Moving on to the last section. So the question we're asking you, write px in the form 2x minus 1 qx, where qx is a quadratic factor. So if you notice, they have a same phrase that they use, okay, or same format that they try to assess you. Okay, all the question about this polynomial topics is somewhat similar. So what you need to do now is the division process that you have learned. So take the a and b's information you identified from the simultaneous equation. You now have the polynomials p as 2x cubed plus 27x squared plus 84x minus 49. Okay, use this information here, okay, and run the division process, and you get x squared multiplied with 2x minus 1, you will get 2x cubed minus x squared. Run the calculation, then you get 28x squared plus 84x. Then I multiply a 14x into it. Then I get 28x squared minus 14x. Find the difference again. Okay, run the calculation. Then you get 98x minus 49. Then you put plus 49 to cancel it off entirely. Okay, so our qx is now x squared plus 14x plus 40 9. For the last section here, okay, factorize px completely. So what they wanted you to do is to factorize the qx that you have there. So x times x equals to x squared. 7 times 7 equals to 49. Cross multiply them. We get 7x and 7x. So since the center value there, we have positive 14x. So I put positive on both. Okay, transfer it up. You will get x plus 7, x plus 7. So it is actually x plus 7 bracket square. So your final answer, your px is actually 2x minus 1, x plus 7 squared. So if they didn't put equals to 0, means they didn't want you to find the x exact value. So all you need to do is to factorize it only. So this is pretty much it for the entire polynomials topic. So if you get any question that you want to ask, you can leave it in the comment section below. Or alternatively, you can post it in my free Q&A group that I created. Okay, the link is also in the description. So this is pretty much it for this polynomials explanation video. I hope you find it helpful. Do share it to your friends that are struggling, and I wish you all the best in your upcoming examination. Thank you.